the heartbeat from beyond. Imagine this. Right now, at this very moment, something is moving through our solar system. Not one of our comets. Not an asteroid we've tracked for decades. Something from another star. Something older than our sun. And as it passes us by, scientists are detecting something they've never seen before. A pulse. A rhythm. A heartbeat. Every 16.16 hours, like clockwork, this object brightens and dims. Jets of material erupt from its surface in a pattern so precise, so controlled, that even the most skeptical astronomers are starting to ask questions they never thought they'd have to answer. Is this thing natural? Or did someone build it? The object has a name. 3I Atlas. And in the next 10 minutes, I'm going to show you why this might be the most important discovery in human history. Or why it might be nothing at all. Either way, you need to hear this story. The discovery that changed everything. July 1st, 2025. A telescope in Chile spots something unusual. At first, it's just another dot of light moving across the star field. But within hours, astronomers realize something is very, very wrong. This object isn't orbiting the sun. It's passing through. The numbers tell the story. This thing is moving at over 137,000 miles per hour. That's fast. Really fast. But what makes scientists drop their coffee is the trajectory. It's not curved like everything else in our solar system. It's nearly straight, like an arrow shot from somewhere in the direction of the galactic center. They name it 3I Atlas, the third confirmed interstellar object ever detected by humanity. The first was Oumuamua in 2017. The second was Borisov in 2019. Now we have a third visitor. But this one is different. This one is doing things that make no sense. Within days of discovery, over 122 observations pour in from 31 different observatories. Everyone wants to look at this thing. And the more they look, the stranger it gets. It has a tail. It has jets. It has a fuzzy atmosphere of gas and dust. Okay, so it's a comet, right? Case closed? Not even close. The anomalies begin to pile up. Here's where things get weird. Actually, let me rephrase that. Here's where things get absolutely impossible to explain. Anomaly number 1. The size. If this is a natural comet, it's enormous. Between 12 and 28 miles across. That makes it roughly 1,000,000 times more massive than the other interstellar objects we've seen. The problem? There shouldn't be enough material floating between the stars to create objects this large. The odds of something this big randomly wandering into our solar system are astronomically low. Like winning the cosmic lottery while being struck by lightning. Twice. Anomaly number 2. The trajectory. This object's path is aligned within 5 degrees of the ecliptic plane. That's the flat disk where all our planets orbit. For a random interstellar object to just happen to line up with our planetary plane, the probability is 0.2%, less than 1 in 500. It gets better, or worse, depending on how you look at it. During its journey through our solar system, 3I Atlas makes close approaches to multiple planets. Venus, Jupiter. The math has been done. The probability of a random object doing this? Less than 0.005%. 1 in 20,000. Anomaly number 3. The composition. NASA's James Webb Space Telescope took a look at this thing in infrared. What they found was shocking. An unusually high ratio of carbon dioxide to water ice. Way higher than anything we see in our own comets. This suggests the object formed around a very different kind of star. An older star. A star with less heavy elements than our sun. Follow-up studies estimate that 3I Atlas is between 7.6 and 14 billion years old. Let that sink in. Our sun is 4.6 billion years old. This object might be 3 times older than everything in our solar system. It was already ancient when Earth was being formed. Anomaly number 4. The color. Most comets are reddish. They reflect sunlight in a way that gives them a warm, dusty appearance. 3I Atlas? It's blue. Bluer than the sun. That's backwards. That's not how comets work. Anomaly number 5. The anti-tail. Comets have tails that point away from the sun because of radiation pressure. Makes sense. But 3I Atlas has jets pointing toward the sun. Multiple images show material streaming in the wrong direction. Sunward jets. Anti-tails. This shouldn't be possible with natural ice sublimation. Yet there it is, clear as day in every photograph. The heartbeat that shouldn't exist. But here's the big one. The anomaly that's keeping astronomers up at night. In October, a team of scientists published something in the journal Astronomy and Astrophysics. They'd been monitoring the brightness of 3I Atlas over several weeks. And they found a pattern. Every 16.16 hours, the object pulses. It brightens. Then it dims. Then it brightens again. Like a heartbeat. Like something breathing. At first, scientists thought maybe it's just rotating. Maybe it has an uneven surface that catches more sunlight at certain angles. That explanation lasted about a week. The Hubble Space Telescope took high-resolution images. Turns out, the nucleus, the solid core of the object, contributes less than 1% of the visible light. Almost all the brightness comes from the surrounding cloud of gas and dust, the coma. So if the core isn't causing the pulsing, what is? The jets. Multiple collimated streams of material erupting from the surface. And here's the thing that makes scientists nervous. These jets appear to be pulsed. Not random. Not chaotic. Pulsed. On a timer. Every 16.16 hours, like clockwork, the jets fire in a coordinated pattern. Material gets ejected at about 440 meters per second. That creates a shell extending about 25,600 kilometers before fading into the background. That scale matches exactly what's being observed. Natural comets don't do this. Natural comets erupt randomly based on where the sun is heating the surface. But 3I Atlas? The jet pattern doesn't fully align with solar heating. The timing is too regular. The direction is too precise. It looks less like geology and more like engineering. Harvard astrophysicist Avi Loeb compared it to a heartbeat. He said, and I quote, "The puffs are periodic, like the bloodstream of a heartbeat. A cosmic pulse from an object that shouldn't be pulsing. An interstellar rhythm that follows its own rules." The alien hypothesis. This is where things get controversial. And I need you to understand something before we go further. Most scientists, the vast majority, think 3I Atlas is a natural comet. Unexplained? Absolutely. But natural. Just a cosmic iceberg with some unusual properties. But there's a minority. A small group of researchers who are asking a different question. What if it's not natural? What if someone built this thing? Avi Loeb is leading that charge. He's the former chair of Harvard's astronomy department. He's not some fringe conspiracy theorist. This guy has published hundreds of peer-reviewed papers. He's advised governments on space policy. And he's saying, very publicly, that we need to take the technological hypothesis seriously. He created something called the Loeb scale. It goes from 0 to 10. 0 means definitely natural. 10 means definitely artificial. Where does he rank 3I Atlas? A 4. Right in the middle between probably natural and worth investigating as potential technology. His reasoning? Look at the evidence. An object with a precisely timed pulsation. Jets that fire in coordinated patterns. A trajectory that brings it suspiciously close to multiple planets in our solar system. A composition that suggests it came from an ancient, alien star system. And a size that shouldn't exist based on what we know about interstellar space. Loeb argues that we shouldn't dismiss the technological hypothesis just because it sounds like science fiction. He points out that we've only been listening for alien signals for about 60 years. That's a blink of an eye in cosmic time. If advanced civilizations exist, they might not be broadcasting radio waves. They might be sending probes. Physical objects that can travel between stars, gather data, and move on. Think about it. We're already planning interstellar missions. Breakthrough Starshot wants to send tiny probes to Alpha Centauri using laser-powered light sails. If we can imagine doing this with 21st century technology, what could a civilization a million years ahead of us accomplish? What could they build? Maybe they'd build something that looks exactly like a comet. Perfect camouflage. It enters a solar system, blends in with the natural debris, and quietly observes. The periodic pulsing? Maybe it's a signal. Maybe it's a power cycle. Maybe it's something we don't have the physics to understand yet. Or maybe it's just a really weird comet. The skeptics push back. Not everyone is convinced. In fact, most astronomers think the alien hypothesis is a massive leap with very little evidence. And they have good reasons for their skepticism. First, the size argument. Yes, 3I Atlas is huge. Yes, the odds of something this large wandering into our solar system seem impossibly low. But impossibly low doesn't mean impossible. The universe is vast. There are hundreds of billions of stars in our galaxy alone. Statistically unlikely events happen all the time when you're working with those kinds of numbers. Second, the trajectory. Yes, it's aligned with our ecliptic plane. Yes, it makes close approaches to multiple planets. But here's the thing. Our telescopes are pointed at the ecliptic plane. That's where we look for asteroids and comets that might threaten Earth. We have massive observational bias. We're more likely to detect objects in that region simply because we're watching it more carefully. So, of course, the interstellar objects we find are going to be in that area. Selection bias, plain and simple. Third, the pulsing jets. Skeptics argue that we're seeing natural outgassing driven by solar heating combined with the object's rotation. The 16.16-hour period? That's just how fast it's spinning. As different areas of the surface face the sun, different ice deposits sublimate and create jets. The pattern seems precise to us, but it's really just physics and geometry working together. Fourth, the composition. Yes, the carbon dioxide to water ratio is unusual. But unusual doesn't mean artificial. It just means this comet formed in a different environment than the ones we're used to studying. An ancient star system with different chemistry would produce different kinds of icy bodies. That's not evidence of technology. That's evidence of diversity in the universe. The scientific consensus is clear. 3I Atlas is a fascinating object that's teaching us new things about interstellar comets. But there's no compelling evidence that it's anything other than a natural phenomenon. The burden of proof lies with the people making extraordinary claims. And right now, the alien hypothesis doesn't meet that burden. What happens next? So where does that leave us? With an object that's already passed its closest approach to the sun and is now heading back out into interstellar space. By late 2025, it'll be too faint for most telescopes to observe. Within a few years, it'll be gone completely, swallowed up by the vast darkness between the stars. But before it disappears, scientists are squeezing every drop of data they can from this thing. The James Webb Space Telescope is tracking its chemical composition. Ground-based observatories are monitoring the jet patterns. Radio telescopes are listening for any kind of signal, just in case. There's even talk of a mission, a fast flyby probe that could catch up to 3I Atlas before it leaves the solar system. It would be expensive. It would be risky, but the scientific payoff could be enormous. Imagine getting close-up images of an interstellar object. Imagine analyzing its surface composition directly. Imagine finding out once and for all whether this is a cosmic iceberg or something far stranger. The problem is time. These objects move fast. By the time we design a mission, build the spacecraft, and launch it, 3I Atlas will be long gone. We'd need to move faster than any space agency has ever moved before. And in the current political and economic climate, that seems unlikely. So we watch, we measure, we debate, and eventually we let it go. The bigger question, but here's the thing that keeps me up at night. This is the third interstellar object we've detected. 3 in 8 years. Oumuamua in 2017. Borisov in 2019. 3I Atlas in 2025. That suggests these things are common. Really common. Maybe there are thousands of interstellar objects passing through our solar system every year. Maybe tens of thousands. We only see the ones that get close enough and bright enough for our telescopes to spot. Which means there could be dozens of objects just like 3I Atlas cruising through our cosmic neighborhood right now. Some might be natural. Some might be probes from civilizations we can't even imagine. And we have no idea which is which because we don't have the technology to investigate them properly. Think about that. We're like people on a deserted island watching ships pass by on the horizon. We can see them. We can describe them. But we can't reach them. We can't board them. We can't find out where they came from or where they're going. We're stuck on our island watching the universe sail past us. That's the real tragedy here. Not that 3I Atlas might be alien technology and we can't prove it, but that we're living in a time when interstellar objects are visiting our solar system regularly and we don't have the capability to study them up close. We're watching the greatest show in the cosmos from the cheap seats. The cosmic perspective. Let me leave you with this thought. Whether 3I Atlas is a comet or a probe, its very existence changes something fundamental about how we see ourselves. For all of human history, we've been trapped in our own solar system. Every rock, every comet, every asteroid we've ever studied was born here. It's all been family. But now we have visitors. Objects from other star systems. Messengers from alien suns. Even if they're just chunks of ice and rock, they're travelers. They've seen things we can only dream about. They've orbited stars that died billions of years ago. They've drifted through molecular clouds where new stars are being born. They carry with them the chemical signatures of environments we've never encountered. And every once in a while, one of them swings through our neighborhood and gives us a glimpse of what's out there. A reminder that we're not alone in the universe. Not because we found alien life, but because we found alien matter. Stuff that doesn't belong to our sun. Stuff that came from somewhere else. That's profound. That's beautiful. And that's worth paying attention to. So is 3I Atlas a cosmic visitor or a construct of another civilization? Honestly, we don't know. We might never know. It's already leaving. Soon it'll be nothing more than a data set. A collection of observations and measurements stored in astronomical databases. But for a brief moment in 2025, it was here. It was real. It was close enough to see. And it made us ask questions we've never had to ask before. Questions about what's possible. Questions about what's out there. Questions about whether we're ready for the answers. The final word. Look, I know what you're thinking. You want a definitive answer. You want me to tell you whether this thing is natural or artificial. But the truth is, the universe doesn't owe us easy answers. Sometimes the most important discoveries are the ones that leave us with more questions than we started with. What I can tell you is this. We're living in an incredible time. A time when objects from other star systems are passing through our cosmic backyard. A time when we have the technology to detect them, study them, and wonder about them. And a time when we're starting to realize that the universe is far stranger, far more diverse, and far more interesting than we ever imagined. 3I Atlas is out there right now, moving away from us at over 130,000 miles per hour. Every second, it's getting farther away. Every minute, it's becoming harder to see. And eventually, it'll cross back into interstellar space and continue its journey through the galaxy. Where will it go next? What star system will it visit in 10,000 years? In 1,000,000 years? Will it encounter another world with another species asking the same questions we're asking right now? We'll never know. But we were here. We saw it. We wondered about it. And that makes us part of its story. If this video made you think, if it made you wonder, if it made you feel something, then do me a favor. Hit that like button. Subscribe to the channel. Because the universe is full of mysteries like this, and we're going to keep exploring them together. There are more visitors coming. More objects from beyond our solar system. More opportunities to ask the big questions. And I'll be here to tell you about them. Because this is just the beginning. The age of interstellar exploration has started. Not with spaceships, but with observation. Not with travel, but with wonder. And honestly, that's a pretty good way to start. Thanks for watching. And keep looking up.